Good evening, guys. So today we're going to talk about hypothesis testing. What is so this is kind of like a little bit different from what we've been doing, but today we're going to talk about determining the null and alternative hypothesis of a given context. So we're going to go over what a null and alternative hypothesis, like what their sort of relationship they have with each other, and how to do that. So what is a hypothesis test? So everything we've been doing in stats leads up to this single point in life. On hypothesis testing, we use statistics to determine the, the probability that a given hypothesis is true. So everything we've been doing from probability to finding confidence intervals, from finding sample means and sample proportions, and finding, looking at tables and, um, you know, what's it called? Quantitative data and lines of best fit leads ultimately up to this point. And so this is probably some of the most important stuff, but like honestly, like you'll see it's super important that you guys get this because you will see hypothesis testing pretty much for the rest of this unit. And by unit, I mean this semester. So pretty much for the rest of the year, get to know what hypothesis test is, live it, love it, worship it. It's the greatest thing that you'll ever come up. So, what is a hypothesis? In science, you do a lot of experiments focused around hypothesis. One hypothesis could be, um, I believe that a potato could conduct electricity. And so you create experiments focused around looking at potatoes and whether or not they conduct electricity. And so, sort of in a similar aspect in statistics, we have a hypothesis. The hypothesis is an assumed parameter. So, a hypothesis could be the proportion of teenagers who drink and drive is 0.4. That would be a hypothesis. And then we would go around collecting data through samples, randomly selected samples, to find out, well, do high school teenagers really drink and drive 40% of the time? Or do 40% of high school teenagers drink and drive? Um, and so with that, there are two important kinds of hypothesis in statistics: the null hypothesis and the alternative hypothesis. Again, two of the most important things for like the rest of this semester. Literally, the two most important things you'll ever see this next semester. So, what is a null hypothesis? We denote it by HO. So you'll hear me saying that a lot. The null hypothesis is your HO. Your HO is your null hypothesis, and I'll definitely be using the two of these um, interchangeably. So the HO is what we assume to be the population parameter. This is the status quo. So that's what we expect to happen. That's what we assume will happen. This picture right here is a band called Status Quo. So again, the null hypothesis is what we expect to happen. What is the alternative hypothesis? Well, we denote that by HA. So again, just like null hypothesis is the HO, the alternative hypothesis is the HA. And again, I'll be using these terms very interchangeably. So the HA is a hypothesis that we think could be possible if we rejected our HO. So if we found enough evidence to say that our HO is not true, then we can say that our HA could be possible. Like our HA could happen. So how are they related? If we find enough evidence to say that the HA is possible, then we can reject the HO. If we do not find enough evidence to say that the HA is possible, then we do not reject the HO. So it's really important. We always reject, we never accept. And why do we never accept? Well, okay, let's look at this. Court cases. If there's this quote by the New York State jury instructions. If the people So the people, if they fail to satisfy their burden of proof, you must find the defendant not guilty. In court cases, our HO, so our assumed status quo, we are assuming in an ideal court case, the HO would be that the defendant is innocent, innocent until proven guilty, um, which unfortunately is not a thing in our nation, but I could go on that for like about 2 hours, maybe more. So our HO is that our defendant is innocent. Our prosecutor is then trying to say there's enough evidence to say that the defendant is guilty or not guilty. They never are trying to prove the defendant is guilty or innocent. If you ever watch like Law and Order SVU or like CSI or something like that, you'll see a lot of times that like they literally show the guy like stabbing the other guy or something, right? But like because the guy who actually stabbed the guy, you know, did some crazy, um, you know, tampering with the evidence or like cleaning up their act, there is sometimes not enough actual evidence to say that the guy killed him. But like we know he killed him, but the court is saying he is not guilty because there's not enough evidence to say he is guilty. So we never say the defendant is innocent because sometimes they aren't innocent. Sometimes they actually did. There's just not enough evidence to say that the person is innocent, which is in the same idea of accepting our null hypothesis. We never say that the null hypothesis is true. We just say that there's not enough evidence to say that it is true, or there is enough evidence, um, or there is not enough evidence to reject it, or there is enough evidence to reject it. If we don't reject it, maybe the scientist or the statistician does another random sample. He tries it a couple more times until he does have enough evidence to reject it. So again, it's really important. Never reject or never accept, never accept, never accept, never accept the HO. Never accept the HO. Always reject. So some notes. The null hypothesis will always equal the assumed statistic, and the alternative hypothesis will either be greater than, less than, or not equal to that statistic. Which makes sense because the null hypothesis is our status quo. We're assuming that our null hypothesis is equal to this population parameter. And the alternative hypothesis would either be less than the population parameter, greater than this population parameter, or does not equal that population parameter. So again, we are never proving anything right. We're only just proving things to be wrong. So in that case, we never accept, we only reject. We never say anything's right. We only say things are wrong or not wrong. That doesn't make it right. It just makes it wrong or not wrong. But unfortunately, we never accept, never accept, never accept, never accept, never accept, never accept. If I see you in class accepting a null hypothesis or an alternative hypothesis, you will get a 0. I promise you. So, examples. Currently, 40% of MIGMUGs like wigwags. Mr. Begbig thinks that the proportion is more than that. So, Mr. Begbig thinks that more MIGMUGs actually like wigwags than people think. So, this is how I want you exactly how to write it exactly on the AP Stat exam. So our HO is P equals 0.4. So get the 0.4 from the fact that 40% of MIGMUGs like wigwags. HA is going to be that the proportion is greater than 0.4. We say it's greater than 0.4 because Mr. Begbig thinks that the proportion is more than that. And so we also have to define what P actually is. So P is a proportion of MIGMUGs that like wigwags. So remember, context is important. Literally, you will not get any problems right if you do not include the context. Include the context. Is a coin fair? So if a coin is fair, we could assume that the HO or the null hypothesis is going to be equal, is going to have a proportion of equal to 0.5. So if I flipped 100 coins, 50 of them would come out heads. HA, P does not equal 0.5 because, well, if P is a proportion of a coin flipping heads, if it flips more than 0.5, it's kind of unfair. So that means if it flips more heads than tails, it might be unfair. But it also flips less heads than tails, it might be unfair. So that's why it does not equal. That's why it's not less than 0.5 or greater than 0.5. It has to be not equal to 0.5 because it sort of can go either way. And 20% of cars of a certain model have needed costly transmission work after being driven between 50,000 and 100,000 miles. The manufacturer hopes that a redesign of a transmission component has solved this problem. So our H0 or HO, excuse me, is going to be P equal to 0.2. And I got this 0.2 from, well, 20% of cars, yada, yada, yada. Our HA would be that P is less than 0.2. So our manufacturer created this redesign of a car, and he's hoping that less than 20% of cars will need to have costly transmission work after being driven between 50,000 and 100,000 miles. So he's hoping that it's less than that. And so P in this case is a proportion of cars that needed transmission work after being driven between 50,000 and 100,000 miles. So yes, if this is confusing, go over the PowerPoint slide. We're going to go over this stuff for like about 5 minutes in class tomorrow, and so we're just going to sort of, well, practice all this stuff tomorrow. It'll be a good day. I'll see you guys later. Good night.